UPM's biorefinery in Leuna will demonstrate that bioeconomy on a large scale is feasible and commercially successful. That is the guiding principle for our next guest, and I look forward to introducing him to you. He has studied chemistry in Leipzig and holds a PhD in chemistry from the Max Planck Institute for Coal Research in Mülheim, an der Ruhr. Before joining UPM in 2021, he worked in the plastics industry. He is the head of UPM Biochemicals Process Development Department in Leuna. His team supports startup and commissioning, long-term process and application development linked to UPM first of its kind wood-based biorefinery. But listen for yourself to his lecture on UPM's first of its kind biorefinery in Leuna. Welcome, Dr. Konrad Gebauer from UPM Biochemicals GmbH Leuna. Welcome.
Thank you for the very kind introduction, and I'm happy to be here today, to be invited and to show you a little bit what is happening right now, roughly 25 kilometers south here of Halle in Leuna. UPM is, as the title says, building its first of its kind biorefinery. Before we go directly to Leuna, we have to take a little detour. I want to show you, first of all, a little bit what UPM is doing and what this is all about. So UPM as a company has around about 55 production sites currently worldwide and 17,200 employees. We are working with wood-based raw materials, and we are producing our own low-carbon energy, and we convert these, raw materials in our production plants to serve millions of customers or end users and over 10,000 customers. UPM, as such, has his home in the pulp and paper industry. So if you look at the business areas here on the slide, you can see that especially the left and the middle columns are, I would say, very classical pulp and paper and forest industry business areas. So UPM has an own forest business unit where we have our own forests and where we manage other forests as a feedstock for our plants. We are working in fiber business and producing timbers and pulp. So we've recently, for instance, inaugurated a new pulp mill in Uruguay with a world-scale output. As I said, we have our own energy business, and basically what we've done probably 20 years ago and are still doing since 20 years are, let's say, core businesses like communication papers and specialty papers. As you might know, communication paper business is a business that is declining due to digitalization and less demand on communication paper as such, but still a very attractive and, let's say, business that brings margin and allows us to diversify our company. One of the things that I would mention there is specialty papers, where we look into packaging, paper packaging. We have a UPM Raflatac, where we especially look on label materials, self-adhesive label materials, and UPM plywood, doing construction plywood or flooring for vehicles like NLG ships, for instance. So, but basically everything goes back to wood and the forest as our resource for industry. As I said, was obvious that paper business will decline, so the company has already decided over 10 years ago to diversify the portfolio. And the, let's say, newcomers to our business areas you can see on the right-hand side under UPM Biorefining. There we have biofuels business, making renewable naphtha and petrochemicals or diesel for the petrochemical industry and also for engines. UPM Biochemicals, this business unit I present today here, where we use wood-based chemicals, or where we produce wood-based chemicals, and then we have as well UPM Biomedicals and UPM Biocomposites as other, say, new technology areas. So the journey for UPM Biochemicals started over 10 years ago in 2012 with creation of the vision and strategy. And then it took roughly 10 years to get to implementation. So this is something to always keep in mind. So we started with broad evaluation of various sites, technologies, and chemicals. Then we were able to boil it down to certain chemicals, and we evaluated the markets. Of course, you need to have a market to sell your products in the end. And then with a pre-selected number of chemicals, we started first feasibility engineering, and then with the selected concept, basic engineering. And 2019 was the preparation for the investment decision by UPM, and early 2020 decision was done that we will erect a first of its kind biorefinery in Leuna. Just starting with a couple of brief numbers. So it is not a demonstration plant, it's not a pilot plant, it's a full-scale chemical plant. We are planning to produce, as you see in the middle, 220,000 tons of products per year. The investment was 750 million euros, and we started construction in early 2021, and we are aiming to finalize construction end of this year and production ramp up next year. For sure, these projects generate new jobs. So right now, we have generated over 100 new jobs just for UPM employees, and currently at the construction site there are over 1,000 people working in building the refinery. As I said, UPM has a strong background in forest industry and using wood as biomass. So one of the clear outcomes of our evaluation in 2012 and ongoing is that wood is the biomass we would like to go for. We have some very strict principles on how we use wood, and they are shown here. So this is a UPM-wide principle. So we are looking at 100% traceability, so we know where we take our wood from. We are targeting to have 100% certified wood material by 2030. And we are also regenerating what we are using. So we are currently planting more trees than we harvest for our processes. So this is currently a number of 50 million trees planted every year, which, if you do the math, is 100 per minute, which is quite a nice number. So, but to make it very clear, let's say bioeconomy for UPM is only possible with very sustainably treated forests as well. So we do not do any deforestation, we are not using rainforests, and we are making sure that harvesting is done in a sustainable way, and we preserve what we also harvest by planting new forests. For Leuna, we've prepared a very simplified biomass checklist. So first of all, it was about defining or asking the question, what would be a suitable biomass type? As I already said, wood was close to our heart, but there are different types of wood species around. Finally, we figured out that hardwood is the way to go for us. In Leuna, it will be beechwood only. And we also said very clear from the beginning, we want to have 100% certified wood, so 100% FSC or PEFC certification. With this in mind, we have screened areas where we would fulfill the demand of our refinery, and we shortlisted finally 10 regions globally. And finally, Leuna was taken as the say, region with good demand, but also good, say, other circumstances to build the biorefinery there. When you decide, and this is probably a little bit what Anne has already said, when you decide to use biomass, you always need to reflect how it is currently used so that you don't compete with, for instance, food industry. Wood is, as you all know, a second generation feedstock. So, and if you look into the use of beechwood, it is 60% incinerated at the moment here in Germany. And fourth point is if you look at forests here in middle Germany or middle Europe, you see that we have quite severe damages over the last years due to drought, due to bugs, insects that damage especially the monocultures of pines and so on. So one of the ideas is to change these monocultures to mixed forests, and mixed forests in Middle Europe are typically beechwood forests. If you leave the forest growth for 50, 60, 70 years, it will turn into a beechwood forest. So somehow we are creating a demand for beechwood, and we are somehow also supporting the transition of the forest here in the region with this. So summarized, we will source wood from federal, state, or private forests, mainly west of Leuna, as you see on the slide. Everything is certified, and if you look on the right-hand side on the current use of beechwood, as I said, 60% is incineration, the rest goes into furniture, industrial wood, or pulp production. And our idea is to take out a fraction of the wood that is currently used to incinerate and transfer it to a material use instead of an energy use. Maybe just a couple of words on beechwood forest management. I guess we are not too many forest rangers here in the room and also online, so that's why I think it is important to explain a little bit what we are actually doing in the forest. So forest has typically three, say, time spans of age. The first is the first 25 years, which is the care phase, where you plant new seedlings and let them grow. Then we have from 25 years, as you see on the x-axis, to around about 100 years, the thinning phase. So you typically plant more trees than you let grow in the end. So you take out selectively some trees and others you allow to grow. So this thinning wood is something that we will use in the refinery. And then around about 100 years, you start to plant new seedlings, say, grow of new trees, and then you can selectively harvest old trees as well. And so the idea for us is to mainly use thinning wood and a bit of industrial wood, and maintaining the forest structure, so no deforestation close to Leuna due to UPM. A couple of words on lignocellulose as a raw material. So if we compare our industry now, or what we are trying to do with the classical fossil-based industry, we have to admit and acknowledge that our raw material is compared to, as I said, the fossil resource high in oxygen, so it has quite some oxygen. So if you look on the right-hand side on the diagram, on the y-axis, you see oxygen content, comparison to carbon content, and you see that cellulose, hemicellulose, and lignin, as I said, have more oxygen in there. That means classical standard processes cannot be, fossil processes can hardly be used to transform a biomass. And if we talk about lignocellulose, we mainly limit ourselves to the main components, which are cellulose, hemicellulose, and lignin, that are biopolymers as such. But we are disassembling the biopolymers and then reassemble them to new polymers. If we look at the process that we are planning to, or that we are currently building in Leuna, it all starts, as I said, with sustainably harvested biomass. This will come to Leuna, either thinning wood, industrial wood, or also, let's say, side streams from other sawmills. This comes to Leuna, and if you look on the left-hand side there, it starts with classical pulp and paper steps. So you have your wood log. First thing you do is you debark the wood log, and then you chip it into wood chips. Then it starts with a pre-treatment process where we convert the wood chips into a pulp material. So again, classical pulp and paper industry. And we already generate one of the first product streams, the so-called industrial sugar stream. It is coming from hemicellulose, so it's rich in xylose. The rest of the material is now transferred from, so if you think about different industry clusters that work together, from the pulp and paper industry to biotechnology. So the next step is an enzymatic hydrolysis. We have a mix of cellulose and lignin, and cellulases create glucose out of the cellulose, lignin remains. We go to a solid liquid separation, and we have an aqueous sugar stream and a solid lignin. And now we are moving into classical chemical industry processes. The sugar stream is converted in a catalytic conversion to glycols, so it's kind of a CC bond rupture, hydrogenolysis, and we end up with two products, monoethylene glycol and monopropylene glycol. We have seen monoethylene glycol in the slides before in this carbon diagram where you're tracing the different, let's say, traces of carbon. On the bottom, you see that we also modify the lignin. Lignin is modified in the so-called RFF process, and RFF stands for renewable functional filler. And the product that we get out of this is the renewable functional filler. I will spend a couple of words to this later on. So as you see, our process is rather diverse, having a combination of different processes. And to get such a biorefinery concept together, you have to partner up and collaborate. So this is key to success here. And not everything that you see here was solely developed by UPM, but we partnered up, we have licenses. So if you, for instance, talk about the sugar to glycol process, this is a license that we have from the Coca-Cola company and the Chinese startup, which is called Maihe. And you can clearly see as ethylene glycol as one of the products, there is a certain interest by Coca-Cola as well. But basically what I say, it was very important in the phases that I've shown you in the beginning to scout for the right technologies and the right partners to set everything together. This is, or here you can see a couple of pictures from Leuna taken, if I'm not mistaken, in May. So this is how the construction site looks at the moment. On the top left, you see our wood yard, and you already see there is beech wood already delivered to Leuna. So we will soon start up with our chipper and debarker, which you see on the top and left side. This white building is the chipper and debarker. And then in the back, the blue, two silos with the blue roofs, these are the chip silos. If we then follow the pictures by looking at the picture on the bottom left, you see in the front again our wood yard. And then, not sure if it is so easy to see here in the room, but there is a little blue conveyor belt running behind the chimney there to our main area, which you can see on the top right side. So this is a picture from the south, and on the bottom you see our product tanks. So just as, let's say, so we are producing significant quantities of glycols, industrial sugars, and RFF as well. And as you see, there are many cranes, many workers. So currently we are 1,000 construction workers on the site, bringing the project further. Now a couple of words to the products and why we are doing things. And I'll think with this slide, I somehow repeat what we have discussed already today in several talks, looking at the renewable carbon cycle. So the idea is, and UPM is part of this renewable carbon initiative as well, is to somehow stop fossil-based carbon and transfer completely to renewable carbon. So we have the production cycle there. So let's say starting from production, we have some loss of carbon during production. We use the material until its end of life, and then we have, so this is probably the cascade use that we have discussed as well. And then in the end, we end up with a recycling process. So overall, roughly 30% of the material is lost, and this needs to be replaced. And the idea is to replace this with either bio-based or CO2-based starting materials in this end. So how does the cycle for UPM look like? Here we have drawn a second renewable carbon cycle, which also incorporates the trees that we are using. So the idea is trees capture CO2 from atmosphere. They need it to grow for photosynthesis. And we are transferring the biomass, as I said, in our refinery into products, and they solely contain bio-based carbon. This is then used, recycled, and at some point at the end of its life, CO2 is most likely being emitted to the atmosphere again, and then it starts the cycle again by using our forests and trees to capture CO2 again. Secondly, and this is something next to the renewable carbon cycle, we also need to make sure that it's not only carbon that biomass is offering us, it's also oxygen, hydrogen, sulfur, nitrogen, sometimes even phosphorus. So I think one of the major, let's say, benefits of the products that we are producing in Leuna is their high oxygen content. So if you look at MEG, for instance, it has a very similar ratio of oxygen to carbon as well as hydrogen to carbon. So in principle, we only need to add a little bit of hydrogen to the whole process to get to the product. So we are not trying to remove oxygen, so produce water as a expensive side product, but we keep it within the products. And this makes our process and our products also quite, let's say, cost competitive. The two products that I would like to highlight here today, and I think I would like to highlight them because they fit to the purpose of our Congress here today. The first one is monoethylene glycol, well known as a monomer for polyesters, especially polyethylene terephthalate. What we produce there is a drop-in chemical, so it's exactly one-to-one what you would get from a fossil-based process. So it is, in terms of quality, purity, not distinguishable. That means end customers can simply use it as a drop-in for their process and run it unchanged. The benefit of using our bio-MEG is a 60% CO2 reduction compared to fossil. And what is also interesting and good to see here, the market demand is high, so it's good to go to large scale with this product. So it is all about PET packaging, polyester textiles, but we also look into other industries like coolants. MEG is an important coolant. Second product I would like to highlight here today is the renewable functional filler that I've mentioned before. This is a new product, so it's an alternative for carbon black, but it is not carbon black. That means you have to team up with the customers and you have to help and support them to make the product work in their current products as well. But we have been very successful with this. You see on the left-hand side rubber material used on the inside on car doors containing 20% of RFF, which gives the producer of these rubber products 30% lower CO2 footprint and also a 10% weight reduction. Of course, RFF is lighter than carbon black. You see shoe soles. You see that we can also use it in thermoplastics like polypropylene, and we can go till final products like the little bottles you see on the right-hand side. Another benefit of developing in new products is that they have new properties, and one of the properties I would like to highlight for the RFF is it is NIR sortable. So compared to carbon black that you do not really see with NIR, you see RFF due to the presence of oxygen. And again, the customers get a 90% CO2 reduction compared to carbon black, and the market demand is rather high. And finally, as this is also a congress where many universities and university partners are around, I would like to highlight that we have not only established the refinery and the connection to the customer, but we have also established an R&D laboratory in Leuna next to the refinery. So the focus is first and foremost on startup and commissioning of the biorefinery and process development, but we are also very open to partner up to do product development, to look at new pathways and do this either in direct collaboration or in exploratory projects or also in funded projects as well. So this is also a call. Whenever you have interesting project ideas that somehow fit to our strategy, please feel free to reach out to us and we see if you can partner and support. And with this, I'll skip this slide because I'm a little bit over time already. A couple of pictures from our labs. And with this, I would end the talk and I'm happy to answer questions.
Thank you so much for the very interesting presentation, Dr. Konrad Gebauer. And yeah, now we can take questions from the audience first. Does anyone have a question?
Please feel free to.
Okay, so please, you can, yeah.
Hi, thanks for the presentation. I have one question. As far as I understood correctly, at the end of the day, from a very, very biocircular material, wood, high polarity, a persistent material like a PET has been produced. And we know that the soil is much, much more polluted than the water systems. So, and that the pure existence of fibers from PET can destroy metabolic processes in the soil. So what do you think? Would the tree think about that issue?
First of all, I'm convinced that trees cannot think. But it is, so I understand what your question is pointing towards. So is it reasonable to make, let's say, a non-biodegradable product out of a renewable resource? Can I rephrase the question like this, or are you pointing in a different direction?
I mean, at the end of the day, everything is degradable. At the end of the day, everything is bio-based, but it's a question of time. Yeah.
Yes, it's a question of time. So if you look on the refinery concept, you have to clearly identify markets where you can sell the product to make it a success. So PET is, for instance, a big market, as I've shown, and that's why we have chosen this as a potential market for us to make things a success. But it doesn't mean that the use of the monomer that we are providing is limited to this. So there, I think, is the opportunity to team up, to partner and get into products that are biodegradable using either these monomers that we provide or monomers that future biorefineries will provide. Are you satisfied with this answer? Not really, huh?
We can talk later.
Okay.
Maybe we have a question from the digital audience. May I hook into that? We've seen that one of your output is industrial sugar. And we all know that sugar is used for the production of PLA, for example. Have you thought about also that kind of pathway to use your industrial sugar output to produce polymers like that?
This is an option for sure, yes. So yes is the answer, and I see someone smiling here in the audience.
Yeah. Or are there any other applications for the industrial sugar stream, what you will produce in future?
So basically the industrial sugar stream is rich in xylose. It is made from the hemicelluloses, and everything you can think of doing with xylose is something you can do with the industrial sugar stream.
Okay.
Okay.
Thank you very
Great.
much.
Thank you very much, Dr. Konrad Gebauer, for being with us.
Thank you for having me here.
Thank you. Great.